A2 further maths, graphing rational functions. Okay, so you've got the graph of f of x equaling x just there. All right, nice straightforward graph, as you know. And what I want to do is find the reciprocal of this graph. So the reciprocal, again, as you're well aware, means it's the 1 over graph. So really what I'm looking for is the 1 over x. Now the truth is you already know what the 1 over x graph looks like. Right? You're already aware of that and you could probably sketch it down for me straight away. What I want to do is just have a look at how this graph here relates to the 1 over graph. Right? How does that graph relate to its reciprocal graph? So the first thing we're going to notice is just that point just there. All right, now that point just there, where the graph crosses the origin at 0, what we notice is if we tried to do 1 over f of x at that point, then what we're going to have is 1 over 0. And we know from our graph sketching experience that anything that tries dividing by 0 is going to form an asymptote. So if I cross just there, which I do, my 1 over graph is going to have an asymptote. Right? Again, you already knew that, okay, because you know the shape of the graph, but it's important to understand why that asymptote appears on the 1 over x graph. What we're going to do now is just going to investigate a few more things about this point just here. If you imagine that you're approaching that asymptote from here, from below it, from the negative direction, then you're talking about, from our x values, we're talking about -1 there, with -0.5, -0.1, and so on. But what we notice is as we're approaching 0, then that f of x could either be 1 over these very small numbers, or 1 over these very small numbers on this side. Now in this case, as I'm approaching from here, because these are negative, 1 over is going to be a negative. In this case, negative infinity. The smaller that x value gets, the bigger 1 over that number gets. And because this is negative, this one's going to be negative. And it works just as well from the other side. If I look at approaching it here, so I'm going from 2 down to 1, down to a half, down to a quarter, down to a hundredth. Well, 1 over a hundredth will be 100. It'll be up here. Now this is the positive direction, so therefore it's approaching the positive part. So I know for this asymptote, I'm basically checking points either side. This side was negative, so therefore it's approaching the negative infinity. This side of it was positive, therefore it's positive infinity. All right, and again, I know this is a very simple example, but it's important to have an awareness. When you find where your asymptote is, check the points either side. Are they positive? Approaching positive infinity. Are they negative? Approaches negative infinity. Okay, so a couple of other things though, it's just worth noting. As your x value or your f of x values get very, very big, okay, so in this case, they are going up higher and higher, and of course they carry on, don't they, all the way to infinity. Now, as they go to infinity, what we're noticing that 1 over that value is going to get very, very small. So when you're getting very big with your f of x, when this tends off to infinity, the 1 over graph is going to get very, very small. And that's what's happening there. So because that's getting very big, that one's getting very small. But also is true for the opposite side. As the negative f of x value gets very, very big, starts approaching negative infinity, 1 over is going to go towards 0 as well. So I know this graph does this, I know it does this, but also because it's approaching both of those, that's where your asymptote is going to be. But now I'm in a position to sketch the graph I already know, and there we go. That's why the graph of 1 over x looks like it does. Okay, because it's a reciprocal of the y equals x graph. Okay, grab your notebooks then, please. So we put this example in our notebooks. First one was a bit too basic, but this one might be a bit tougher. So I want to look at the reciprocal graph of 2 minus x squared. Now I've either drawn that, I have to sketch it myself, or I might be given that graph and I just need to find the reciprocal graph from it. Okay, so what I'm going to do is I'm almost like an algorithm. I'm trying to remember certain things. I'm trying to think what happens where the intercepts are, what happens either side of the intercept, what happens when f of x gets really big, and things like that. Okay, so let's make a bit of a note. To sketch a reciprocal, the first thing I want to do is consider some of these important points. So the first ones is the intercepts with the x-axis. Now I know that everywhere this graph intercepts the x-axis, the 1 over graph will have an asymptote because it's at 0. So I know straight away these two lines are going to be there. The next thing I'm going to do is just check, is it approaching from minus or is it approaching from positive? If it's approaching from minus on this side, we know it's going to be minus infinity on here. As this side is approaching from minus, this side will be minus infinity. Okay, just be aware it's not always going to be the same on both bits. It could be a situation where you might have a graph that just touches and therefore positive on both sides. But this one, definitely approaching a negative because it's negative on that side. Check the opposite as well, just make sure. So on this side of the asymptote, it was positive. On this side of this asymptote, it was positive. So therefore, it's going to be positive for both of those. So checking either side of your asymptote line, either side of where the graph crosses the 0. So there we go. Started off, got my asymptotes, got where it approaches at asymptotes. That's a good starting position. The next thing I need to do is intercepts with the y-axis. So we didn't do this on the previous one because it crossed at 0, 0. But if we look at where it crosses the y-axis just here, crosses at 2, when we look at when it crosses the y-axis for the 1 over graph, well, in this case, whatever a is, the f of x function will be 1 over a. So because this was 2, the 1 over graph will be 1 over 2, which is a half. Right, so it's always the opposite. Because that was 2, this one will be 1 over 2, which is where the half comes from. Not a direct reflection, which some people make the mistake of, but because 2 goes to 1 over 2, that's what I've got here. So I can see a graph that's sort of coming like that, crosses there, does something else on this side. Okay. As f of x tends to infinity, so what we need to be doing is looking at both of these sides. I've noticed that this graph just here gets very big and it's negative. Okay, so it's going down towards negative infinity. 1 over negative infinity is going to approach 0 from the negative side. Same here. As x gets really big, f of x tends off to negative infinity. So 1 over negative infinity is going to be getting closer and closer to negative 0. So both of those are approaching the 0 line from below. And I think that's probably enough to give myself a sketch. Before I do that, I want to look at any stationary points. Now in this case, the stationary point is exactly the same as where it crossed the axis. It's not always the case, but it is worth just pointing out. If I look at the stationary point just here, which was back to 2 again, what happens is it it goes to 1 over. So in this case, we've just seen this where it intercepted the axis, but it's also true for any turning point or any stationary point. So the stationary point here was 0, 2. So when we look at the reciprocal graph, the 1 over graph, we notice that goes to still 0, but goes to a half. Okay, and that's what it's saying there. Investigate the stationary points. What happens to a stationary point? Well, any stationary point that has a set x value and then the function f of a retains that a value, that a value stays the same, that x value stays the same, but the y value goes to 1 over that function. Okay, and we'll look at another example in a second where we've got other stationary points. And once I've done that, I can then fill in all the extra parts to produce the graph we want. Okay, so let's try this one. You notice this one has a stationary point moved, so it'd be important to make sure we plot that one as well. Okay, so you might want to just have a go yourselves on that. Okay, so let's see how far we got. So the first thing I want to consider is where it crosses the x-axis. It doesn't cross the x-axis in this case, so there should be no x-intercepts. Okay, so that means I need to move on. I need to move on to the next bit. I'm going to plot the y-intercepts. I've noticed that it crosses just there at roughly about 1.5. So it's going to cross down here at roughly 3 over 2. 2 over 3, sorry. All right. So there we go. I've plotted that roughly. Yes, you could work out the exact answer where it crosses, but it's only a sketch. So as long as you're roughly about right, looking at that, 3 over 2 goes to 2 over 3. Okay, so what next? Well, I need to look at where it goes off to infinity. I've noticed it's going to go off there, it's going to go off there. So far, it's going to come up, it's going to cross just there, but then it's going to go back down to here. So I've got this sort of graph. And I wouldn't blame you at all for doing that up to its maximum point and then go down to there. But we do need to investigate the stationary points as well. So there's my stationary point. Notice it's at 1, 1. So where does that go to? That's going to go to 1 across. It's going to retain that. And the up value goes at 1. So 1 over 1 is back to 1 again. So really, this graph just here has a stationary points at 1, 1 as well. So what does that mean? I can now sketch the graph, and there we go. That's the graph of 1 over cosh x minus 1. Okay, or you can write it as sech x minus 1. Okay, so we're going to look at another example. And the reason why we're looking at this example, because this one has an asymptote on the original graph. So we want to know what happens to asymptotes. So first thing I want to do is same as before. Start with thinking about the x-intercepts. I know the x-intercept is at half, so therefore that produces an asymptote just there. I want to investigate either side of that asymptote, either side of that asymptote, yep. So where it approaches 0 here, it's on the negative side, so therefore it approaches negative infinity on that side. Where it approaches this one is positive, so that will be going to positive infinity. Then once I've got both of those, I can then investigate, in this case, the asymptote. So I know there's an asymptote just here, okay? And the reason for that is because the graph is trying to do 1 over 0. All right, it can't be 0 down here because that's at minus 1. But if I'm doing the reciprocal graph, and that 0 as the denominator goes up to the numerator, that would be perfectly acceptable. And that's exactly what happens. That asymptote just there, due to the fact you're trying to divide by 0, or when you invert it, there's 0 as a numerator, and that's perfectly fine. In fact, if the 0 is the numerator, the whole thing would be 0, which is why it crosses at 0 just there. Anything that intercepts at 0 becomes an asymptote on the reciprocal graph, but anything that's an asymptote always becomes 0. They're flipping. Remember, these two are the reciprocal of each other. So any rule that goes from there to there also follows to go from there to there. Okay, so it's important to recognize that the two graphs are the reciprocal of each other. Right, so there we go. I know it crosses at 0, so I'm guessing this is going to come down here and cross there. What I need to do now is go to the next part and look at any y-intercepts. Now it crosses at 1. What does that mean then? Well, it crosses at 1 over 1, which is still 1. So there we go. I know the graph's going to come down like this. What does that mean then? It's got an asymptote through minus 2. Okay, and the reason why I know it crosses at minus 2 is because this asymptote used to cross here at minus 2. There we go. And if I want to find out where that new asymptote goes to, it's the same rule for finding y-intercepts. It crosses at minus 2, so 1 over that minus 2 would go to minus a half. Right, these values just here are minus 2, so 1 over it is going to go to minus a half. So horizontal asymptotes follow exactly the same rules for any intercepts with the y-axis. So anything along the y-axis, right, just does 1 over it. Okay, that's the same for stationary points, that's the same for intercepts, that's the same for horizontal asymptotes. Anything to do with the y, because that's the f of x, becomes 1 over f of x. Anything to do with the x's, that does do some changing about. Right, so what does that mean then? Then I know it's got an asymptote just there, but I need to be aware of what's happening either side of that asymptote. So just here, it's approaching when negative infinity is below it. So what I'm going to do is it's going to be changing to above it. Okay, so anything there that's going down to that side will become this side here. It changes. On this side, anything that approaches below it there will go above it here. Okay, so they flip him round. And that allows me to finish off sketching that graph. And notice it is just the graph of 1 plus x over 1 minus 2x, which you could have plotted in your first year just using your rational function skills. What I'd like you to do now is just have a go at sketching some of those graphs, practicing those different skills, sketching what happens at stationary points, sketching what happens at intercepts, sketching what happens to horizontal asymptotes. Okay, so have a go at all those things on exercise 4A on page 64.